Welcome all of you to Ganit Samvad lecture series on mathematics. Last lecture we have seen about the set. Now in this lecture we'll continue with the set for class 11th Cbse. We'll cover these points in this lecture: union of sets, intersection of sets, universal set difference, complement of a set, and De Morgan laws. These points we are going to cover. Now first is union. What is the mean by union? When we perform operation of union, which is denoted by U on two sets, say A and B, we obtain a new set denoted by A union B. That is, if we are having two sets A and B, and if we perform operation of union on the set, then we get a new set which is denoted by A union B. This is new set. Now we define this new set A union B as follows. What is the definition? A union B, it contains all X such that X in A or X in B or in both. So it contains all elements which are either in A or in B or in both. That is, this new set A union B contains all elements of A together with B. Let us see this with the Venn diagram. This is A set, this is B set, and A union B is whole this set including the set A and set B both. Now let us see an example. Suppose A is equal to 1, 2, B is equal to 2, 3, then A union B will be 1, 2, 3. All elements of A, all elements of B. 2 is coming 2 times, but it is not repeated in a set. The element is written once only. So it is 1, 2, 3. Note that A is subset of A union. Why? Because A is only this set is A, but A union B is whole this set. So A union B is A is contained in A union B. Similarly, B is a subset of A union B. Now the question is, when X does not belongs to A union B, that is, if I take any X which is a element of universal set, when this does not belongs to A union B. So you can see with this Venn diagram, it is very easy to understand that if X lies outside A and B, if it is not in A, if it is not in B, so it will not be in A union B. So answer is, if X neither in A nor in B, that is, if X does not belongs to A and X does not belongs to B, then X will not belongs to A union B. Now, if we are given the n set A1, A2, An, and if we find their union, we get a new set. This is represented by this way. Now, let us talk about the intersection of. So, what does it mean by intersection? When we perform operation of intersection denoted by this symbol on two sets, say A and B, we obtain a new set denoted by A intersection B. A is set, B is set. We are performing operation of intersection. So we get a new set which is denoted by A intersection B. Now what are the elements of this new set A intersection B? So we define A intersection B as it contains all X which is in A and B both. So this new set A intersection B contains all common elements in A and B. Let us understand this by Venn diagram. This is your A set, this is your B set, and this is the common portion which is in A and B. So this represented by the new set. This is the new set A intersection B. For example, let us take A is equal to 1, 2, B is equal to 2, 3. So what is the common element? The common element is 2. So intersection B is 2. Now note that this common set, that is A intersection B, it is in A also and it is in B also. So we can say that A intersection B is a subset of A and A intersection B is subset of B also. Now again the question, if I take any x, then when x does not belongs to A intersection B, that is, if we take any set x, any element x, when it does not belongs to A intersection B. So clearly, in this case, the situation will be either x is over here, but it is not in B, or x is over here, but it is not in A, or x is outside of this two. So answer is if either x in A but not in B, or x in B but not in A, or if x is neither in A nor in B. That is, when x does not belongs to intersection B, if x belongs to A but x does not belongs to B, or if x belongs to B but not in A, or x does not belongs to A and x does not belongs to B. Now intersection of n sets, if we are given this n sets, then the intersection is represented by this, and this is the A1 intersection A2 intersection up to AN. Like this way we write the intersection of these sets. Now universal set, what does it mean by universal set? The universal set U contains all the elements under consideration for a particular discussion. All other sets are subset of this universal set. It is denoted by symbol U. Let us understand this by an example. If you want to partition even and odd natural numbers less than 30, then we can take this as a universal set, that is all numbers from 1 to 30. And then if we take A, that is the odd numbers less than 30, and let us take B as a even numbers less than 30. So these are the subsets of this universal set U. Now let us talk about the set difference. What does it mean by set difference? When we find difference of the set A and B in this order, that is A is first and B is second, we get a new set which is denoted by A minus B. From this two, when we find the difference, we get a new set, that is A minus B, which contains all elements of A that are not in B. In notation, A minus B contains all x belongs to A which does not belongs to B. In Venn diagram, we can see these all elements are in A but they are not in B. So this is A minus B. For example, if A is equal to 1, 2, 3, 5, B is equal to 3, 4, then what is A minus B? We will have to identify those elements of A which are not in B. So 1 is in A but is not in B, 2 is in A but not in B, and 5 is in A but not in B. So A minus B is 1 to 5. Now let us talk about the complement. The complement of a set A is again a new set which is denoted by A dash. So with A, if we find the complement, then we get a new set, that is A dash or AC. It contains all elements of U which are not in A. So A dash contains all elements of universal set which are not in A. For example, let us take U is equal to 1, 2, 3, 4, 5, A is equal to 2, 4, and what will be in A dash, that is in complement of A, 2, 4 is appearing over here, remaining element will come in A dash. So 1, 3 and 5, that will be A complement. Now note that this is, if this is universal set and this is A set, then outside this is A complement. And if we find the A union A dash, that is if we include A and A complement, then we get a universal set. And if we find the intersection of these two, because there is a no common element in A and in A dash, so its intersection is always 5. Now when x does not belongs to A dash, or when x belongs to A dash, the answer is if x does not belongs to A, then it will belongs to A dash. Now when x does not belongs to A dash, the answer is if x belongs to A. So this is very clear. because their intersection is always 5. There is no common element between these two sets. Now let us see De Morgan law. It says that complement of A union B is intersection of complement of A and B. So this is A set, this is B set. We have to find first of all their union. So this is its union, and we have to find its complement. So this area, outside of this area, this is represented by this A union B is complement. So this is A union B complement. For example, let us take A is equal to this set, U is equal to this set, A is equal to this set, and B is equal to this set. Then A union B will be clearly this, and its complement will be 6, 7. Now we find first of all A complement. From this it is very clear that this will be A complement. From B, this will be B complement, and if you find their intersection, it is 6, 7. So both these are equal. So this is justified by this example. Now let us see the proof quickly. How to prove De Morgan law. If you want to prove this too, so we'll have to prove that first of all A union B dash is A, because we have to prove that these two sets are equal. So this should be subset of A dash intersection B dash. That we'll have to prove. So how to prove? As I told you the method, in general, we will have to take an arbitrary element in left side, means in this set. Now it is in complement of A union B, so it will not be in A union B. Now if it is not in A union B, it means it cannot be in A, it cannot be in B. Because recall that this is A union B. If X does not belongs to A union B, that is, it should be outside this X, A and B. So it does not belongs to A, it does not belongs to B. Now if it is not in A, then where it should be? It should be in A complement. If it is not in B, then where it should be? It should be in B complement. Now it is in A complement and B complement both, so it belongs to their intersection. So how we have started? We have started and taken an arbitrary element in A union B's complement, and we have proved that this element is in A dash intersection B dash. So clearly, again by definition, complement of A union B is subset of intersection of A dash and B dash. Similarly, conversely, what we'll have to prove? We'll have to prove that A dash intersection B dash is contained in complement of A union B. So again, the method will be same. We'll start with, we'll take an element X belongs to intersection of A complement and B complement. This will implies that X belongs to A complement, X belongs to B complement. So this implies that if X belongs to A complement, it means X does not belongs to A. X belong to B complement means X does not belongs to. Now X is not in A, X is not in B, so it cannot be in A union B. But if it is not in A union B, so where it should be? It should be in its complement. So we have started with an element which is in intersection of A dash and B dash, and we have proved that this belongs to complement of A union B. So clearly A dash B dash, intersection of A dash and B dash is contained in complement of A union B. So by this two, this is the first and this is the second. These two sets are equal. So by this way we have proved the De Morgan law. Now the second law is complement of A intersection B is same as union of complement of A and B. Let us understand this by an example. This is represented by, because A is over here and B is over here, A intersection B is this, and we have to find its complement. So all the portion which does not lie over here, so that will be your complement of A intersection B. Let us understand this by an example. Let us take U is equal to this, A is equal to this, and B is equal to this. So what will be A intersection B? This will be N. What is the complement of A intersection B? This will be this set. And what is A dash? A dash will be this set. B dash will be this set, and their union is again same as M, O, P, Q. So clearly these two sets are equal. So we can say this is proved with a particular example. In general, we have not proved this, but this example verify that this law is true. Now this Beamer presentation can be downloaded from the link which is given in the description. If you have any suggestions, you can write in comment box. Also, if you like this video, then share with the others. In the next lecture series of this series, we'll discuss about order pairs, Cartesian product, and relations. Thank you.